Forgot this from geometry, applications of right triangle trees. You have angles of elevation and angles of depression. Elevation, right, going up from some horizontal line. Angle of depression, the angle going down from a particular horizontal. As you can see, I have Senor right here. He's looking straight across. When he looks up, that's his angle of elevation. When he looks down, that's his angle of depression. Okay, so the key thing about these is to remember that it always comes from some horizontal line, and then from that horizontal line, either looking up or looking down, that is the angle of either elevation or depression that is created. All right, an observer stands 100 meters from the base of a building. The angle of elevation to the top of the building is 65 degrees. How tall is the building to the nearest meter? Okay, so the important things here that I would need if I were to create a picture, what would I need for one? I would need, what type of triangle?
Right.
A right triangle, okay? So let's go ahead and let's specify what each of these sides will represent. What would this side represent here?
How far is from the building?
How far is from the building? So this would technically represent the ground, right? And so this would be what?
The height of the building.
The building, the height of the building. And the angle of elevation would be 65. Is it the angle at the top or is it the angle at the bottom? At the bottom, because there is your horizontal line, and then going up, there is your angle of elevation to the top of the building. And how tall is the building to the nearest meter? Where's the 100 go? Goes on the bottom. And so we can easily set this up using what? Tangent of what? Equals x over 100. Simple enough, right? Key thing, you gotta make sure that you draw a picture. Am I dividing here or am I gonna multiply at the end of this? I'm gonna multiply 100 by the tangent of 65, which is
214 meters.
because we want to make sure that we round to very significant figures unless it says otherwise. Okay? Shouldn't be nothing too strange looking. Familiar, right? Okay. Something maybe not so familiar. Okay? I don't know if any of you all drive or have the GPS feature in your car. They might have like the northeast, southwest, right? Y'all seen that before? Maybe a long, long time ago? Or you just know it?
I have it, but I don't use it.
You have it, but you don't use it? Okay, well that's in relationship to, a map. Like, are you driving north? Are you driving south, east, west, so on and so forth, okay? These are known as your compass points, okay? A lot of times they might use compass points when they're talking about a ship, a plane, and they also might use bearings to solve a problem, okay? So they do something like this. They're talking about north 40 degrees east. That's 40 degrees east of north. So if you look here, here's the north direction. I'm traveling 40 degrees east. East is over here, okay? So that angle is created using the north and then traveling towards the east direction to create that 40 degrees. So north 40 degrees east would look like this. Does everybody understand that? Here's another example. West 20 degrees south. That's 20 degrees south of west. So I'm coming from the west direction, heading south. So here's west. South will be going down, and there's 20 degrees. Yeah? And then if they just say northwest, or they just say southwest, or northeast, or southeast, that is exactly 45 degrees between the north and the west direction. Okay? So here's that example over here. I don't know if you guys know that never eats sour worms. Soggy waffles. Gotta be real. I've never heard soggy waffles till I came here.
This children's one of soggy waffles.
Gotta be real. I promise you. Sour worms
makes so much more sense.
Bearings. I don't know if you guys know about bearings. Bearings is another way to basically represent like compass in the degrees, okay? So if you have 0, 35 degrees, that is 35 degrees clockwise from the north direction. Key thing about bearings is bearings are always from the north direction. Okay, so if they say 35 degrees, a bearing of 35 degrees, start in the north direction, travel clockwise 35 degrees, okay? 110 degrees clockwise, 110 degrees of a bearing would be 110 degrees clockwise from the north. So you've already traveled the full 90 degrees and the additional 20 degrees after that from the north direction. Okay? Lastly, a bearing of 270 degrees would be 270 degrees clockwise from the north direction. So as you see here, I've traveled 90, 180, and lastly 270 degrees from the north direction. Okay? All bearings are from your north direction. So just make sure you keep that in mind. So your question, do they always go clockwise? Yes. Always clockwise from the north direction.
What if it's negative?
If it's negative 35, so then instead of going clockwise, you would go counterclockwise. But I've never seen a bearing that is negative. Yeah. Usually they would all bearings are usually in the positive direction. And so they might say a bearing of 310 degrees, you're still going from that north direction.
Why do you turn the ship around?
Maybe they made a mistake. Maybe they made a mistake and they have to.
It's just directions. You don't have to turn the ship.
Here's one that's starting on your paper. Two ships leave the dock at the same time. Ship A travels due north for 30 kilometers before dropping an anchor. Ship B sails on a bearing of 050 degrees for 65 kilometers before dropping anchor. Find the distance between the ships when they are stationary to the nearest kilometer, okay? Something that might help you here, a picture, right? So, I need a dock in my picture. And I need two ships. One ship is ship A, sails due north 30 kilometers. So I'm going to draw my line straight up. It is going to end up forming a triangle. So we have 30 kilometers before ship A drops anchor. Then ship B sails on a bearing of 050 degrees for 65 kilometers before dropping anchor. How would I represent that bearing of 50 degrees? Clockwise starting in the north direction. So nope. So there is your 50-degree bearing. And he travels for 65 kilometers. And then drops anchor. We are trying to find the distance between the ships when they are stationary, so we are looking for the distance between A and B.
This is always the right triangle, right?
Not always. Okay? So let me actually draw this a little bit better. Because 65 kilometers is longer than 30, right? So this is actually going to extend a little bit further than F. So let me do it. Okay? This does not form a right triangle. However, we could create a right triangle to figure this out, right? It might, but because we're practicing some right triangle work right now. We haven't gotten to log sines or cosines yet, okay? We're practicing a little bit of right triangle work, okay? You have to use right triangles to solve this. How would you do that? Make a line from A to the hypotenuse. So you're saying go like this. Form a right triangle this way. Okay. All right. Okay. You have to use right triangles. If they tell you that they want to see it this particular way, you got to be able to do it. Yes, there's another way you can do it, of course. It's easier. It's a simpler way. However, they might actually do this. So would we just get 1 point taken off the rest? You probably get 0 points if you didn't do the way they actually do.
Wait, did they say?
Okay, right here. I'm telling you how to
No,
do
but
it.
I'm saying like on the test will it say?
Yeah, on certain test questions, it'll say.
That's what that's fine. Yes.
Okay, right there.
Right where?
Okay, you see where you made the 90-degree triangle, that
Yes.
angle?
Uh-huh.
Right, you go across, go, keep going. Go, follow the 90, yeah, right there, that's 40. And
Not the big side, the small side, that's 40.
This is 40?
Yes, ma'am, and
Okay.
that makes the big side on the other side 140 also.
You mean the angle?
Yes, ma'am.
Okay.
Okay, and you can do the right, you can do sine to find that angle, that
No
line.
sine.
You can't.
No
For the
sine.
right triangle, you can.
To find this dotted red line, you could use sine.
You just said you.
Well, maybe not sine, but you could use a trig one. Which trig one could you use to find this dotted red line? Tangent. Because you know this for sure is 30. You don't know exactly how far you've gone on that 65-degree line. Okay? So let's find that red dotted line by using tangent. Tangent of what? 50 degrees equals
X over
x over 30. Am I multiplying or dividing here?
30.
Multiplying by 30, tangent 50.
35 points.
5.8.
8.
Yeah.
Okay, so we know that dotted red line is 35.8 kilometers. Okay?
So then you could
You could use.
so wait, and now that we have the right triangle, we have all that side. For the bigger one, are we allowed to use?
No, you could use cosine to find the AB, couldn't you? Is that
No,
allowed?
I'm asking for that other triangle, we can just use like cosine or OB.
Yeah, cosine of 140, couldn't you? Don't mind.
It's not a right triangle.
Could you split it into more
Create more right triangles? Where?
Because when I started, I was thinking like if you just went straight down and you made 2 right triangles out of that.
Yeah.
And
What do you
then-
mean straight down from B?
Yeah, like instead of that red dotted line, like forming, just going straight to that so that there are 2 right triangles. Like
So say going here
No,
and
like
then over.
from A to straight down. Straight down to, no, other,
right.
diagonal line, no, the diagonal, no, the diagonal.
Matthew, shush, use the points.
Okay,
Point 8 to
line A cuts through B dock. What?
Yes, gotcha.
so that it's like this.
No, and then like the straight line.
So that you don't really turn over and
Oh, you're talking about forming one this
Yes,
way and
yes.
making that. Okay. That makes a little more sense. Okay.
Triple diagonal.
Yeah, you gotta give me some reference points here. Alright, so another suggestion we could have done. You said form a right triangle this way.
Yeah,
Right.
that's
So you have 30, 50 degrees, and then
But then that means there's
40.
2 right angles.
And then you could
So this would be
use like
40 here.
tangent and cosine.
so then we could use tangent and cosine again to basically kind of figure this out, and then we would have, yes, it's another way, okay? So then let's do that, does that change this? No, this doesn't change
Did
this.
we have finished the other one or no?
From this point, all we have is this. We would probably have to create another right triangle if we were to go about it this way.
So if-
But we can still use this to find this length, can't we? Or do we have to set up a different one? A different one, which one?
You could do sine,
Sine of 50 equals
x over 30.
x over 30. When I multiply 30 by the sine of 50, what do you get?
22.98, but 23, about 23.
Yes? Confirmation? 23? Alright. This is about 23. Keep going.
And then you know that angle, well, I don't know how to.
The angle,
I know which one I'm talking
like across from the 90, we know that that's another right triangle right there.
Mm-hmm.
Can we just do
about. And then you can find the top angle, like on A, and that's 50. It's 40, no, never mind.
You can't do that. It's not
That's not
right.
right.
I know this whole side is 65 from B to the dock. Let me make another letter. Let's say C. Can I find the distance from the dock to C
Yes.
using what?
Pythagorean.
Pythagorean theorem. Yep. or cosine. So they said we're not using the rounded answers.
Why didn't round it? I used the precise answer,
It's perfect, exactly.
which is 19, about
19.3? Yeah?
You gotta check it.
Yeah, that's right.
19.3, so this is about 19.3, then what's the distance from B to C?
45.7.
45.7 about. So then to find AB, we could do Pythagorean theorem. So let's do that, let's do Pythagorean theorem.
So I got, I had D51,
No.
the nearest kilometer.
Ah, yeah,
Can I get a second? Or a third actually, because you seconded.
Well, yeah, that's how I got it.
You first did it, I second.
Here we go. Okay? It's good to know multiple ways to do these problems because you never know when they might specify how they want to see it. Okay? Questions? Coordinate axis in trigonometry, okay? The angle theta has a vertex at the origin. A positive angle is measured counterclockwise or anti-clockwise from the x-axis. They can use either counterclockwise or anti-clockwise. They mean the same thing, okay? When you're in a said unit circle or you're on a coordinate axis, it's usually measured in a counterclockwise direction, okay? If you look at this particular drawing here, okay? You have your angle theta that comes from the x-axis that is created. A point that's on a circle drops down to create a 90-degree angle. Realize that this point of xy can also be found by taking the cosine of the angle and then the sine of the angle to find that specific point. Okay? Cosine is x when you're looking at a coordinate plane, and sine is y. Alright? So in this particular example, when it asks you to find the exact point of coordinate D, you would take the cosine of 59 to get your x value, the sine of 59 to get your y value, which would be those respective values to 3 significant groups. That would be your location. Questions on this particular example? So if they ever gave you a degree and they asked you to find a particular point, you can use that again as with sine and cosine to find your respective points of location. Let's look at these two examples. Find the coordinates of D. Given that particular circle, what would I do to find the coordinates of D? Cosine 20 and the sine of 20. Which would be what?
49.
And 0.342? Yes?
Yes.
Okay, over here, find the value of theta to the nearest degree. How would you do that? It's time to go on it backwards. How would you find the angle?
Inverse.
The inverse of, so cosine inverse of 0.408, you said? To get what? 65.9. You can also do it by taking the sine inverse of the y coordinate, and you should get the same thing. Don't confuse boys. There we go. Realize they're not going to be the exact same because these were rounded answers, or rounded points. right coordinates. Someone up, yes? Now we all know that. Alright. Now we all know that when you're looking at a particular coordinate plane, your first quadrant of both coordinates are both positive, yes? Second quadrant, they are what? Negative positive, third quadrant, and fourth. Positive, negative, good. Do realize that because of that, for supplementary angles, theta and beta, okay, they can represent any two particular values. That the sine of alpha is equal to the sine of beta, okay? So if you are dealing with supplementary angles mean what? Add to 180. So if you have one angle here and then another angle over here, their sine values are going to be equal because if you look, sine is which coordinate, x or y? They're both going to be positive, okay? That's why their sine values are going to equal each other, okay? So say you have a 30-degree angle here and then a 150-degree angle here. Their sine values are going to be equal. And their cosine values are basically going to be opposite of each other, okay? So the cosine of 30 degrees is going to basically be the cosine of 150 degrees, except one of these is going to be negative, okay? So for any angle theta, the sine of theta is equal to the sine of 180 degrees minus theta, and cosine of theta is equal to negative cosine 180 minus theta. This right here is called an identity. If you were in pre-calculus, you did a lot with identities, yes? Like double angle, half angle, Pythagorean, I think another one. Sum and difference identities. You guys remember those? If you haven't taken pre-calculus, do not worry. You don't have to worry about those extra ones, okay? I'll tell you the ones that you'll need to know and be able to use. This is good to keep in mind so you're not trying to sit there and try to figure out, okay, what is the measure of an angle of 134-degree angle when they already give you the measure of a 46-degree angle. Okay?
Is that supposed to be a negative cosine?
Yes. Because if you find the cosine of one angle that's in the first quadrant, then its supplementary pair is going to have the same value except it's going to be negative because you're in the second quadrant. Questions? Question?
He was asking A and B. What did A and B do?
Alpha and beta, they just represent angles. Same thing that theta is. Okay? You will see pretty much most of the Greek alphabet used. Alpha, beta, gamma. They won't use delta to represent an angle because delta usually means a change in a variable, so like slope, they'll use that there. So do realize you're going to see all your different Greek letters. Okay? So we're going to look at these examples here. Examples 10 and examples 11. We're going to find the value of theta for each of the given positions of point C. We're going to give your answer to the nearest tenth of a degree. And we're going to find one acute and one obtuse value of A. For these examples, you might want to go back to your regular notes, because after this we're going to be back to regular sheets of paper. Okay? For those that might be stuck, how would you find an angle in number 10 in general? What would you do? You can do inverse cosine or inverse sine. What about how would you find one acute or one obtuse angle?
You do the inverse sine thing and subtract that 3 from 180.
There you go.
And for 10. I did both of them and I got two different answers.
You did it wrong.
Yeah,
No, I did it.
I did it as well, and I was like two answers.
I did. I did the inverse cosine and the inverse sine. Different answers.
Yeah.
It's because one of them is negative. Remember that. The cosine.
First off, when you look at each one of those points, what quadrant are you in?
The one on the left.
Top left, so you're in the second quadrant, okay? Now just talked about that. Realize that if you're looking at supplementary angles, okay? If you're looking at supplementary angles, the sines are going to be the same and the cosines are basically going to be the same number but opposite signs, okay? So if you're in the second quadrant and you do the cosine inverse of, what was it, negative 0.332?
Yes.
It's the back, oops, I am in radian. You got this, correct? And then when you do the sine inverse of point,
943.
what do you notice?
Different.
They are different.
They pretty much add up to 180.
They add up to be 180. Okay? You're in the second quadrant. So if this is negative, okay, to figure out the corresponding point, you would need to do what to this?
180 minus.
180 minus that value, okay? And then you would end up with the same answer, okay? So yes, if you did do the positive version, I'll round the same answer because of course they're rounded three significant figures. You would get the same point. You get the same degree, okay? But the thing is that since these points are located in the second quadrant, which number do you want? You're in the second quadrant, those are values that are between what numbers? 90 and 180, so which number do you want? Do you want the 70 number or you want the 109 number? You want the 109 number because it's bigger than 90 but less than 180. You're in the second quadrant. So to find the value of theta, these are all second quadrant points. You're going to want the number that's in between 90 and 180. You're going to get the same situation for B and also for C. When you do the cosine inverse of negative 0.955, and then the sine inverse of 0.927, you're going to get two numbers that are not the same. Two numbers are going to add up to be 180, but when you look at the value, you're going to want which one? You're going to want the bigger one. Okay? So what you guys get for angle C for B in example 10? And what was this one? Was this 109 point something?
109.4.
So you had around 10 years 10 for this one? And all that represent an angle that's in the second quadrant. What about over here? So find an angle. You took the sine inverse of this decimal. And what value did you get when you first took the sine inverse? 60, what? 60.6. So then this would be your one acute angle. So to find the obtuse one you would do, subtract it from 180 to get. There you go. And you keep going. What about for this one? What was one of your angles? 25.8. That was your acute angle. So then your obtuse angle would be? Yes. And then for the last one, what would you get? The last one? 0.7.
So wait, the first one, why did we have to find y?
Why do we have to find what?
Why did we just do
Well, if we did do the sine inverse, let's say for the second one of 0.297, it would have given us an angle that was not in the second quadrant. This is in the first quadrant. So then you would use the fact that the supplementary angle would have the same sine value, and so then we would just subtract that from 180 degrees to get 162.7. It has to match the fact that this point is located in the second quadrant and this angle is in the first. All right. You can also form lines within these coordinate planes, of course. Okay? Now the line y equals x forms theta with the x-axis like before. That point on the circle, xy, can be represented as cosine theta, sine theta. And old school Pythagorean theorem of a squared plus b squared equals c squared can be transformed into a coordinate plane as x squared plus y squared equals 1 squared, which is just 1. Or cosine squared theta plus sine squared theta equals 1. This right here is known as your Pythagorean identity.
And you can play around with that thing.
And you can play around with this, meaning you can subtract a cosine squared theta over, you can subtract a sine squared theta over, and use that to help you
So,
in solving problems.
was this the thing where it was, like 1 minus cosine squared theta equals sine squared theta?
Mhm.
All of those things. Then you gotta move that.
Of course, I'm forgetting that tangent theta equals sine theta over cosine theta. And for any line, y equals m times x, that's slope-intercept form, m being your slope. The value of m is tangent theta. So you can find that value by taking the tangent of theta.
What is the mean gradient of
Gradient is another word for slope. So do be aware if they use gradient, they're just talking about the slope of a particular line. Okay? You will need to know your Pythagorean identity. Okay? So that cosine squared theta plus sine squared theta equals 1. You're definitely going to need to know that. Alright? We might use it a little bit right now, but when we get to circular functions, which is after trigonometry, you will use that a lot. Okay? Along with a few other identities. So we're gonna look at an example of this. And continue moving forward. These are kind of, most of this stuff is just like the basics. Just make sure you guys know this, okay? Your quadrants, where it's positive and negative, or negative and positive, what point, what quadrant. Being able to find the cosine of these angles, or to be able to use a particular point to find the angles. All right, all this is going to play into when you get to further on in this unit, as well as in your circular functions unit. You guys ready? So find the gradient of this line shown. That 60 degrees is located where? In that second quadrant. To find the gradients,
take tangent, right?
you would take the tangent of, okay? Well, let's see, what is the tangent of 60 degrees? 1.73. What's the problem with this?
That's positive.
It's positive and our slope is negative. So, you can easily do what? Easily make it negative, or what could you have done?
Tangent of 180 minus 60 is 120.
And what's the tangent of 120 degrees?
Negative 1.73.
Where'd the 120 come from?
It's a one, it's 180 line and it's on the second coordinate, so. It's on that side.
Your angles are always based off of your x-axis heading in a counterclockwise direction when it's in the coordinate plane. So you want to have used 120 degrees versus the 60 to get the actual slope without having to worry about converting it to a negative. Okay? I don't know if you're going to lose a point because you use 60 instead of 120.
Well,
I don't think so.
well, I think the method's quite wrong, but I get the accuracy right.
Yeah.
Questions?
I have one too. This is stupid.
Sine rule. Should look familiar. Sine rule and cosine rule are what you use when you have a non-right triangle. A non-right triangle is the ratio between the angles, the sine of the angles, and their corresponding sides. Do you realize that the angle is across from its respective sides? So angle A is across from side A, angle B is across from side B, and angle C is across from side C. Okay?
We're gonna be using
That'd be nice.
That's in the rounds.
Yeah. The one thing about cosine, I think they only give you, one, they don't give you one for the angles. I mean, you can always alter it. I do realize that sine, if you recall from, you do not need to set up every single ratio, okay? You probably at most only use 2 at a time, okay? So if you know angle A and side A and you're looking for angle B, but you know side B, then you're only going to use these first 2, okay? Or if you know B and C information, you only use those parts, but you're not going to use all 3 ratios at the same time. Now remember, sine rule was the one that had the ambiguous case. You guys remember that one? It was going to be an acute triangle or an obtuse triangle, meaning you have multiple triangles. So let's refresh y'all's memory of that from Algebra 2 and pre-calc for those who had it. Find the missing angle and sides. You would use sine rule here because you have side, and angle. Okay? You know an angle and the side across from it, and you know just another random side. So we can set this up by saying the sine of 98 degrees over its corresponding side, which is equals the sine of what angle? B over 9.4. So I'm looking for a side or an angle here. You're looking for an angle, and whenever you're looking for an angle, are you going to use the regular sign or are you going to use the inverse of sine? Inverse. So to solve this, we cross multiply. 9.4 sine of 98 equals 12 sine of angle B. How do I solve this? Divide by 12, and then take the inverse of sine. So to find B, you would take the inverse of sine, which is confirmation. I couldn't tell if it was 50 or 15. 50. 50. 50.9?
Yeah. I would have said 15.
I thought you said 15 too, so I was like, I need confirmation.
15, yes.
I got it, there I go, right, 15. 50.9 centimeters. Yes? Good stuff.
No, angle.
Degrees.
Yeah.
Good.
You
Look
can
how I'm
do
looking
that
at you at
so
15.
you kind of go like
Said 15. Like,
Yeah.
it's like, it's 15 or 50. Alright. So then, what can we find next?
Okay, add them together, 180 minus that, you get big angle, big C.
Then you can find C. Then you can find C.
Which is,
subtract away.
Yeah. About. Okay? Now realize if you do 180 minus 95 minus that long 50.9 whatever decimal, then you'll have a 31.1 long decimal after that. Use that to help you find C. Don't round. Okay? Because I'm telling you, sometimes the mark scheme does not give the 3 significant figure answer as an answer that's acceptable. Okay? So how would I set it up to find side C?
sine 31.1 long decimal.
Over
C,
C equals
whatever that number was, 998 divided by 12.
sine 98 divided by 12. Use the angle that's already given to you. Okay, so they gave you 98 and 12. Use that to set up your other proportion. Okay, and you see how I put the dots after that 31.1 number? Now mind you, I don't know if it was like 30.09. That's where y'all got that point from.
31.1305.
So by putting the dots there, it lets the grader know that you are using the long decimal to get this next answer. So put the dots to distinguish them. So then that way they'll know, basically, if your answer turns out different from what's on the mark scheme, they'll know by this that you used the long decimal and maybe something was wrong in your calculation part. Or,
So no matter what, you're gonna get wrong, it's wrong.
no, not necessarily like say this is correct, but your answer for whatever reason, say you divided by 11 because you're typing too fast or something. You know, instead of saying, or multiplying by 11 instead of multiplying by 12. You get the method point because you did use that if something happened between there and final answer. So multiply. Something else, if you notice, I wrote down everything all the way up to would be equal. This is also good because you can get an accuracy point because you need to divide by 12 and then take the inverse of sign instead of jumping from here to here, which some of you guys did on your test last time. You jumped from here all the way to here, and that was 4 points in between the beginning and the end. That heaven forbid if you got it wrong, they can give you. Just putting that out there.
In my head, we take chances.
By all means,
Be quiet.
go ahead. What am I typing into the calculator?
Cosine 31.1. Then you're gonna divide by sine 38.
Are you doing the long decimal?
I don't have.
I did the long decimal, but I think something's wrong.
But you think something's wrong. That's never good.
I got 36.4, which
I got 6.2.
You already got
I got
6.2.
okay.
You guys use long decimal.
Yes.
I did use the long
I
decimal.
just-
6 point.
6.26.
Yeah.
6.26, he said. Is that all right now, right, what he said?
Yes. Well, no, I rounded it to the near 10 because the problem is in the 10.
This here is not an example of an ambiguous case, okay? Ambiguous case is used when you have two angles and a side. That's when you need to check for the ambiguous case, which I believe is our next situation, okay? Or is it?
I was just-
Wait, no.
This is a regular.
One of these is ambiguous case.
How?
Wait, no.
No, it's not this one. I think it's angle side is the ambiguous case.
This one is.
It's one of the ones coming up. Let's do this one. I'll give you guys a second to do this one. This is not an ambiguous case. Find our sides and angles. Round to the angle A. Yes. You have two angles already, and you're looking for the third. So you said 46?
64.
64. 64 degrees. Okay. So then how'd you set up to find side C?
Sine 77 over 40.5.
Over C. So when you got to your calculator, you should have typed in 40.5 sine of 39 over the sine of 77, yes?
Yes.
And you got two decimal places,
46.36.
36?
I got
37.
Oh,
Oh, no, never mind. Yeah, I got that. 0.16. 1.6.
1/6?
Yeah, 1.6.
Okay.
They're right.
Yep. Yeah, because it's 26.15.
The A.
And then how we set up to find side A?
Sine 77 over 40.5 equals sine of 64 over 8.
So then for A, you should have gotten 40.5 sine of 64 divided by the sine of 77, yes? To two decimal places, that's about what?
37.36.
Yes? Good stuff. Questions? Try to set up a picture for this. A ship is sailing due north. Captain sees the lighthouse 6 meters away on a bearing of 32 degrees. Later, Captain observes the bearing of the lighthouse. Okay, here we go. All right, so ship is sailing due north. Okay? Captain sees the lighthouse 10 kilometers away on a bearing of 32 degrees. So he's sailing, and then on a bearing of 32 degrees,
Yes, you're thinking right.
bearing of 32 degrees, he sees the lighthouse 10 kilometers away. Okay, so as he's traveling north, he sees the lighthouse is 10 kilometers away on a bearing of that. How would I draw that? 32 degrees clockwise from up here down here. Okay?
You're gonna go pretty good distance.
Okay? So this is 32, and is this 10 or is this 10?
That's 10.
Later. So see that? Later he observes the bearing of the lighthouse is 132 degrees. How far did the ship travel between those two observations? So how do I represent that?
Would you put the line at the bottom and then draw the other one? So you're over the triangle?
It's like that. So it's like this, and then it looks like this. You wanna see my picture? Because I don't know how to explain that.
I'm thinking,
This from here, maybe.
Like that.
you know, like this is higher and
Yeah, well, honey, what are your angles?
So-
32, 132.
So to my understanding, what I see on two of you guys' papers is that they're traveling some more,
Yeah.
and then the bearing to see the lighthouse is 132. So here's the lighthouse, and then on the bearing of 132 degrees, they see the lighthouse. That's what you're saying? No?
No.
Okay, so then I need someone to come up here and
That
draw
makes
this
sense.
thing. I don't think I'm understanding you. So let's just be clear. So technically, I do understand what you guys are saying, just a little more like a ninth grade. That's why I labeled it. Okay, so that way. But, so, yes, we started off 32, there was the 10, so let me fix on your picture. And we're trying to figure out the distance from when you saw the lighthouse of those two different places. So you're looking here for X. This is correct. Here's the lighthouse. Let's find X. Find X.
The
180 minus
132.
180 minus 132 is 48.
We know
there we go.
And
No,
then
no, no, what's up with the 44 next to the
44.
10?
That's not a 44, that's lighthouse.
Okay.
See, I didn't put that.
And then you got the 100 by doing 132 minus 32, right? Correct?
No.
No, you just go-
48.
So
Well,
just
my
so
way
that we're
works too.
clear,
My way works too.
the 100 comes from the fact that this is a 130 degree bearing. There's 48 on the inside because they're supplementary angles. 48 plus 32 is 80. Subtract that from 180 and you get 100, right?
So how does that work though? Like how does the way I did it work?
I didn't hear what
You got 132 minus 32
Oh,
equals 100.
I don't think they'll work all the time.
You got lucky, I think.
I discovered a new law.
let's see if it works every time. So how would I set this up to find X?
Sine 48 over 10.
48 over 10.
Equals sine x over
Draw it there.
Sine 100 over x.
Sine 100 over X.
You know
Very
what?
good.
You know what I meant.
So to find X, I'm going to multiply sine 100 by 10 and then divide it by the sine of 48 to get.
13.3.
You guys agree?
Yeah.
Good stuff. Here's the next one. In a triangle, ABC, that's not on your paper, so you gotta draw it. On the board, ABC, doesn't matter where you put A, B, and C, it all matters where the angles go. Angle A is 40, side A is 14, which is located across. And C, lowercase c is 20, so that's across from C. Solve this triangle, give your answer correct to one decimal place. Now, this is a side-side angle where you have to check for the ambiguous case. First thing to do when you're checking for ambiguous case is to do what? What do you think? Find the angle. Which angle are we going to find here?
C.
C. So we'll set it up. Sine of 40 over 14 equals the sine of C over 20. How to find C? Multiply by 20.
And with that answer, get the inverse sine then.
But I need to make sure before I take the inverse sine, I have to do what?
All sine by 14.
Divide by
You
14.
do all- listen, I plug sine 40 and divide 14 in, and I get the answers, and I do all my stuff. I don't write it out like that.
66.7.
Yeah.
And then other stuff, because ambiguous.
So 66.7. So that's the first thing. You want to find your angle. Then from there, you need to check to see if you're going to have one triangle or if you're going to have two triangles. So there's the possibility that you can have a whole new triangle where angle A is still 40, side A is 14, side C is 20, but angle C is going to be what?
180 minus 66.
180 minus 66.7, which is what,
113.
113.3.
3.
You always check for this. And then you want to see if you actually end up with an angle B. Okay, a new angle B. Can you find that third angle?
Yes.
And it's not a negative, it's a positive?
Yes.
What number is it?
26.7.
There's 180 degrees in the triangle. And since this actually is a positive angle, that means there's going to be two triangles here, which means you're going to have two sets of answers. Okay? So you're going to have an answer for triangle 1, and then you're going to have your answer for triangle 2. That's how you check for ambiguous case. Once you find that first angle, you need to see if there's going to be a second triangle. To do that, you find the second potential angle C by subtracting it from 180. Okay, that's where the 113.3 number came from. And then we actually try to find my second angle B. Because if you do get a positive number like we did here, you have two triangles, so two sets of answers. If it's negative, what does that mean? That one doesn't count and you only have one triangle. And then you will find the other side B for both triangles and then the last angle B up there.
Patrick,